Hello everybody, Dave Monson here with the draft unit plan. Uh, I don't have this on a screen share thing with you, so I'm just going to share the unit plan document along with this video later on. But let me go walk you through it verbally. My lesson focus is understanding exponents and radicals and how they can be applied to real world situations. And this meets the state standards of 8th grade math of expressions and equations, A.1 and A.1 and A.2. All the times that I'm teaching them about exponents deals with A.1. The times that I'm telling them about radicals like square roots and cube roots is A.2. The language function, higher level Bloom taxonomy that we'll be using is demonstrate, discuss, apply knowledge, analyze patterns, solve, and create. And the vocabulary that they're going to need to know is integer, multiplication, division, positive, negative, exponent, power, root, radical, squared, cubed, and apply. And what writing or speaking levels will they need in order to succeed? Students will need to be able to communicate their thinking through speaking, using mathematical symbols, and through writing. Now, the big picture of this, the flow that things will be going through in the lessons, is that students will learn about positive and then negative exponents of positive integers, including the zero exponent, and then using those same exponents on negative integers. And they'll then learn about square and cubed roots of relatively small perfect squares and perfect cubes, including negative cubes, and that the square root of 2, or actually the square root of any number that is not a perfect square, is irrational. And they'll learn that exponents and squared and cube roots perform opposite and complementary functions. And with this knowledge, they'll learn how these functions, particularly exponents, can be applied to real-world situations. And they'll demonstrate this knowledge by creating straight math and word problems that will be used in other classes that are covering the same material. And therefore, they'll be getting problems that other classes have made for them. And they'll demonstrate their understanding of the concepts by taking a test that includes the problems that the other classes have made for them, as well as things that I've generated. So, the first 3 days of instruction are going to deal incrementally more and more on use of exponents. Day 1, the learning target is I can show what positive exponents are and how to multiply them and convert them into integers. So I'll be using strictly positive integers and having them multiply, say, the base, which is the number up to which the exponent is applied. For instance, 2 to the second power times 2 to the second power becomes 2 to the fourth power. The rule there is that you simply add the two exponents together. And they'll be doing that this first day. And they'll be working individually and in groups. And they'll discover that any number, n to the first power, equals that same number. n, for example, 3 to the first power equals 3. The formative assessment that I'll use is that they'll complete an exit ticket, including problems given to them, and then they'll also create math problems with the format of n to the a power times n to the b power equals n to the a plus b powers. Day 2, the learning target is that I can multiply positive numbers with positive and or negative exponents. So we're introducing negative exponents to still the positive integers as the base. And this includes also the zero power. And let's demonstrate how they're expressed. And again, they're working individually and in groups. and they'll discover how numbers with negative exponents are expressed. So they'll be adding exponents in multiplication by multiplying or adding the exponents. Although this time they could be adding, say, 2 to the third power times 2 to the negative fifth power and end up with 2 to the negative second power. And because 3 plus negative 5 equals negative 2. And that's how you're adding the exponents, even though you're adding negative numbers in the exponents. And they'll be able to explain why numbers with negative exponents are expressed as fractions. And they'll be able to explain why any number n to the 0 power equals 1, including negative numbers. So that's day 2. And again, they'll be completing an exit ticket, doing the same kinds of things as the previous day, only they'll be using more and more, they'll be using today's knowledge. For instance, they'll be creating math problems with the format of n to the a power times n to the b power equals n to the a plus b powers, including problems where the exponents may be negative. And they'll create problems including exponents equaling 0 or less. So they could have something where it ends up with, like, say, 2 squared times 2 to the negative 2 power equals 2 to the 0 power, which would equal 1. Now, day 3, the learning target is I can multiply negative numbers with positive and or negative exponents and identify patterns and show when the results of the exponential multiplication will be positive or negative. So now, instead of having positive integers as the base to which the integer exponents are applied, I've now got negative integers to which the exponents are applied. And again, working in groups, students will identify the pattern that negative numbers with even numbered exponents will end up being positive, while negative numbers with odd numbered exponents will end up still remaining negative. And they'll discover this is also true for negative exponents, like negative 2 to the negative third power will end up being, let's see, it would be, I believe, negative 1/8. And they'll apply this to the multiplication or adding of positive and negative exponents to negative numbers. So doing the same thing as the previous day, except we're using negative numbers as the base. And the formulative assessment is that students will complete an exit ticket again, including problems given to them. They'll also create math problems, so they're getting into a habit of creating math problems with a format of negative n to the a power times negative n to the b power equals either positive or negative n to the a plus b, depending on whether the a plus b exponents is odd or even. And problems given them and problems they create will include exponents equaling 0 or less. Day 4 will be different, because here we're moving into 8.2, part of the state standards dealing with radicals. And so the target here is I can demonstrate how square and cube roots are the opposites of numbers that are squared or cubed, and calculate perfect squares and cubes and explain why all other square and cube roots are not rational numbers. That's the student's goal. And so in groups, again, students will discover the reversibility between square numbers and square roots, and cube numbers and cube roots. For example, 2 squared equals 4, while the square root of 4 equals the square root of 2 times 2, or simply 2. After calculating the perfect squares of 0 through to 12, and the perfect cubes of 0 to 10, students will then apply the reversibility concept they've learned to associate the square and cube roots with their corresponding perfect squares and cube numbers. They'll understand the square and cube roots of numbers other than perfect squares and cubes, respectively, are irrational numbers. For example, we know that the square root of 4 is 2. We know that the square root of 9 is 3. Well, what's the square root of 7? It's somewhere between. And so it's got to be more than 2 and less than 3. But you can approximate it, probably decimally. And the formative assessment here will be, give a set of flashcards to each group of students, table groups, with problems of numbers of 0 to 10 cubed and 0 to 15 squared, and have them square those or cube those respectively. And the square roots and perfect squares from square roots of 0 to 144 and cube roots of 0 to 216 or 1,000. And wander the room to assess students' comprehension of these things. How well are they getting it right? Day 5. The learning target is that I can apply my knowledge of exponents and square and cube roots to real-world situations and demonstrate this knowledge by creating math and word problems for the unit test. And so I'm going to present them several situations. For example, how many great-great-grandparents do you have? Because it becomes an exponent of 2, depending on how many generations you go back. And there could be other things, such as how a chain letter is sent. If I were to send a chain letter to 5 different people and told them each to send it to 5 different people, how many people would receive a chain letter at the 4th or 5th iteration of this? If a virus were to be spread, if I meet 3 people and each of them catches it, and each of them meets 3 people and catches, all 3 of those catch it, how many get their virus through so many levels of iteration of getting if I'm using that word correctly rather, through so many levels of the virus being spread. And if they have any ideas as to other ways of doing this, like videos going viral, controlling for variables so that it keeps multiplying evenly. This is a way of looking at exponents. Or if there's a way of showing how a disease could reduce population, how would that be an example of roots, square roots or cube roots? Or for instance, a perfect example for square roots is single elimination sports playoff brackets. You go from the Sweet 16 in basketball down to 8 to 4 to 2 to 1. And the formative assessment here is that working in groups, students will submit a math plan, a math problem, and a word problem to the teacher for possible inclusion in a different class's test the next day, because the next day will be the summative assessment for what they've been learning this week. So day 6, the learning target is I can demonstrate my knowledge of exponents and square and cube roots by doing my best on the test. There is no formative assessment today, it's the summative assessment. And the student's learning will be assessed by taking a test covering the material presented, and appropriate modifications will be given for those who need it. And this will be covering both of the learning targets in the state standards. And the assessment plan here is that they'll demonstrate their content knowledge in 2 ways. First, by creating problems for other students in other classes, and how well did they do, were they correct in figuring out the answers to those, and how well do they do on the test themselves. And word problems will assess the student's ability to apply the concepts to real-world situations, because when they read somebody else's word problems that they've given them, or the ones I've given them, they have to be able to interpret the facts and then apply them to the math and then come out with the right answer. And that's my unit plan. Thanks.